Hello, I'm Don from Dino Ventures. I want to talk to you today about fossils. Fossils are the remnants of creatures that died hundreds of millions and thousands of years ago, up until about 20,000 years ago. When we talk about fossils, we're not talking about actually the real bones of the animals, because the bones of the animals have dissolved and they have been replaced by minerals that have seeped into where the bones were, and they've turned to rock. That is true with the exception of some parts of animals like the woolly mammoth. Woolly mammoth about 30,000 years ago, when they died in the ice, sometimes their tusks were preserved, and this is actually part of that. It turned to, it's still ivory, but it's got minerals in it. As you can see, it's no longer the creamy white. It's kind of a tan color. And that is part of a woolly mammoth. Now, fossils can still tell us a lot. Scientists can look at them and find out where the blood went through the fossils and where the muscles attached, and if the animal had an injury or a disease. They've even found teeth in bone where another dinosaur had bitten this dinosaur. Tell me that isn't rough. They have found so many things in dinosaurs, and they can learn so much. And not only dinosaurs and animals turn into fossils, plants turn into fossils, insects turn into fossils. Just about everything turns into a fossil. You know what else turns into a fossil? You know what happens when you eat? You know what happens when a dinosaur eats? They poop. This is actual fossilized dinosaur poop. Now, why is that important? Why would that be important to a scientist? That's important because if you would look in this, you would see parts of bone. If you saw parts of bone in dinosaur poop, which is actually called a coprolite, what would you think? What kind of dinosaur would have bone in its poop? Plant eater? No. Meat eater? Yes. Now, the size of this, you think it would be a huge giant Tyrannosaurus? No. It'd be a smaller dinosaur. Okay? It could be some type of raptor. It could be, I don't know, some type of Tyrannosaur, but definitely not a huge T-Rex, Gorgosaurus. Could be an Albertosaurus, but not a huge meat eater. But speaking of huge meat eaters, before Tyrannosaurus, there was a predator that was known as the Wolf of the Jurassic, and that was the Allosaurus. And he was one mean dude, okay? But like all other dinosaurs, he died. And this is a fossil part of one of his legs, okay? The way scientists can tell what these are is when they find them, they're usually broken up, but they put them back together and they can tell what they are. But some of them are just so broken up, they just can't really, it's not feasible to put them back together and make a really sense of them. So they sell them to people like me. But if you look right here, you can tell where one of the nerves ran through, right there. Also, you can tell what the dinosaur was doing at the time. This comes from the leg of a Tyrannosaurus rex. Interesting about this fossil, it's also from the leg. But if you look right here, right in here, inside is fossilized marrow. Inside this is the marrow. We have marrow in our bones also. That marrow does a couple things. It makes blood. That's what makes blood in us. That's what makes blood in the Tyrannosaurus. However, in this particular bone, this particular marrow tells us this was a female Tyrannosaurus. And why? Why is that important? because that means this Tyrannosaurus was storing up calcium to make eggs. Okay? That's very important to scientists. So we know that she was about to lay her eggs when she died. Now, how come a fossil is made? When an animal dies, and it dies in a stream or near a stream, it's covered over. It has to be usually covered over really quickly before it decays. And then it's covered over with silt or volcanic ash, and then it's compressed and compressed. And then the insides kind of rot away. But it leaves a shell. And this shell is filled with those minerals I was telling you about. And after millions and millions of years, and it's pressed and it's pressed and it's pressed, you have a fossil. But it can be underground for maybe a mile. So how do we find it? Well, as the tectonic plates, which rub together, it causes ones to shift up and down and up and down. Earthquakes also cause rocks to rise and fall and everything like this. And then we have wind erosion and water erosion, and that wears the rocks away until we find the fossil beds. And scientists know where to look for those. And that's how we find the dinosaurs from millions and millions of years ago. But we don't have to go to millions and millions of years ago. Not too distant past, we had ancient whales. And this is a tooth of an ancient ancestor to the sperm whale. Okay? And it was a very mean sperm whale. It wasn't like the nice whales you might see at SeaWorld. It was a very voracious carnivore. Okay? If you would be swimming with this thing, you would be lunch. Okay? So we find these quite common. All right? It was called a Balissasaurus. And it lived about, maybe 2 or 3 million years ago. And it was the ancestor to the sperm whale and the killer whale, or the orca. So, not too terribly long ago, in geologic time speaking. So I hope you've learned a little bit about fossils. And it's always good to read books and learn more and explore your world. And thank you.